Then moving on to the next one, right? What is work? Right? What is work? Now suppose that you have an object here like this. You have an object like this, object at the point A. Now this particular object is weighing something around some 100 kgs. Is weighing something 100 kgs. Onto this particular object, if you are trying to push this particular object with one hand, right? This object is not changing its position. But even then you are applying, even though you are applying certain amount of force onto this particular object, this object is not moving, right? You are applying a force of some 10 newtons. Force is applied, but you are not able to change the position of the object. Then in that particular case, are you producing some amount of displacement here? No. So then in that particular case, the amount of work done is said to be equal to 0, because we are not producing any change, we are not producing any displacement. Suppose that onto this particular object, you are applying certain amount of force. You are applying a force of something equal to, right? So onto this particular object, you are applying on the object of 100 kgs. On an object of 100 kgs, you are applying a force of something around 50 newtons. The moment you apply the force, the position of the object will be changed from the point A to the point B, which means the object is covering certain amount of distance from point A to point B, maybe 1 meter or maybe 10 meters, right? You are applying force. At the same time, the object is producing, the position of the object is changing from point A to point B, producing certain amount of displacement. So whenever force is applied on any particular object, if that particular applied force produces certain amount of displacement, then we say that work is said to be done. Work is said to be done by any particular thing, right? Work is said to be done by any particular force, if at all, if it is able to produce certain amount of displacement. Now suppose that onto this particular wall, right, the walls in the house, if 10 persons are trying to push the wall, will the wall move? No. But even though we are trying to push the wall, there in that particular case, the force that is applied on the wall is producing 0 displacement, as a result of which the amount of work done is also equal to 0. The moment you apply force, if it suppose that if at all 2 or 3 persons are trying to push a car, the car will start moving, right? Because of the applied force, the car is moving from point A to point B, as a result of which you are able to produce certain amount of displacement. Then we have done certain amount of work in that particular case. Work is said to be done in that particular case. If at all the applied force, work is said to be done by any particular force. Work is said to be done by a particular force, if at all, if it is able to produce certain amount of displacement, then in that particular case, we say that work is said to be done, right? And that particular work is given by the formula W equal to F dot S, or else sometimes we write as Fs cos theta, where theta is the angle between the force that is acting on the object and the displacement that is being produced, right? Where theta is the angle between the applied force as well as the displacement that is being produced between F and S. So that is what sometimes we write as Fs cos theta, or generally we take it as W equal to F dot S, depending upon the competitive exam or depending upon the examination. If at all you are writing for your intermediate level, definitely we need to go for W equal to F dot S or else Fs cos theta. School standards we write up to W equal to Fs, because there in that particular case we need to talk about scalars and vectors. So to avoid that, sometimes when the angle is not mentioned, we simply take it as W equal to F dot S or else simply Fs, right? But we are supposed to take it as Fs cos theta, provided if at all you are aware of resolution of vectors. But that particular thing is not required for the exam, for the competitive examination point of view. So that is the reason why simply we take W equal to Fs, or else we take it as Fs cos theta, provided if theta is mentioned. Then the amount of work done. Now suppose that you are doing certain amount of work, you are trying to apply certain amount of force on any particular object, right? So the amount of force that is applied on any particular object it is produced, if at all, if it is producing certain amount of displacement, then we say that work is done. So here in this particular case, the work done can be of three different types. The work done can be of three different types, right? The work done can be positive. The work done can be negative. The work done can be equal to 0 also. The work done can be positive, the work done can be negative, at the same time the work done can be even 0 also. Now if at all you recollect, even the case of displacement also, the displacement that is covered by an object can be positive, can be negative, at the same time displacement can also have a 0 value. If at all starting point, ending point both are same, displacement is 0, right? If at all you are moving in a straight line path from point A to point B in this particular path, then the positive displacement, right? At the same time, suppose that you are moving from the top of a tower from this particular point to the ground, in that particular case displacement is negative, right? You are moving in a circular path, displacement is 0. Moving on a circular path, displacement is 0. Moving on a straight line path, here it is 0, here it is positive, here in this case it is negative. Similar to that one, even the work done can be positive, at the same time can be negative, at the same time it can be 0. Now suppose that when work done is positive, if at all the applied force and the displacement, both are in same direction, in that particular case work done is said to be positive. Force and displacement are in same direction, in that particular case work done is said to be positive. Now suppose that for example you take a syringe, right, the one with which you take the injections. The moment you are pushing the syringe from the back side, right, the length of the syringe is moving, the length of syringe is getting decreased, the syringe is moving inside, right? Force as well as displacement both are in the same direction. That is the reason why work done is said to be positive. At the same time, you take the case of a cycle pump. The moment you push the cycle pump, when you are applying force to the top, the length of the cycle pump decreases, the cycle pump starts moving in the downward direction, as a result of which the amount of work done is said to be positive, right? At the same time, suppose that in a particular surface, in a particular floor, right, in a room or in a particular place, suppose that this is a room. Now in this particular room, at one particular corner, I have got some bags of rice. I have got some bags, right? Each bag weighing something around 25 or 30 kgs. I want to change the position of this particular bags from this point to this point, from one corner to other corner, right? Now when you are lifting each and every bag, you are lifting the bag from this particular point and placing it here at this particular point, from point A to point B. Now here in this case, the moment you lift this particular object, right, so there in that particular case, the amount of force, that is the gravitational force that is acting on the object, is always in the downward direction. The force is always acting in the downward direction. At the same time, in which direction you are moving? You are moving like this. You are moving like this. Now what is the angle here? 90 degrees. The angle between these two things, between the force and the displacement, is 90 degrees. And we know that W equal to Fs cos theta. If theta is equal to 90 degrees, what is cos 90? 0. Then that particular case work done is equal to 0, which means that as long as you are doing certain amount of work in a particular horizontal surface, the amount of work done is always equal to 0. The amount of work done is always equal to 0 if force and displacement both are perpendicular to one another. If force and displacement are in the same direction, work done is positive. If force and displacement are perpendicular, work done is 0. At the same time, suppose that this is a surface. Now here I have an object here. When I lift this particular object, against gravity, the work done is something equal to negative. So whenever you are doing certain amount of work, right, whenever you are lifting a certain amount of an object from the surface to air, the work done is negative in that particular case, because there in that particular case we are lifting the body against the gravity, as a result of which work done is negative here. So in some cases work is positive, in some cases work is negative, right? Work done is positive while lifting a box, right? Work done is negative while lowering a box. Gravity, it does positive work, gravity does negative work, the different cases, right? At the same time, when you are doing zero work, now suppose that you are trying to push this particular wall. When you are trying to push this particular wall, the wall is not moving. Since the wall is not producing any certain amount of displacement, work done is zero in this case. At the same time, suppose that if you are moving this one, force is perpendicular to the motion. So then again in this particular case, work done is said to be zero in this particular case, right? Then the next one, that is friction, right? Now here when talking about the case of friction, a table on which you are placing an object, right? When you are trying to push this particular object in this particular way, right, there is certain amount of opposing force between these two surfaces, and this particular opposing force between the surfaces, that is what you call it as a frictional force, a force which opposes the relative motion between the two surfaces. Here in this case, what are the two surfaces? This is the first surface, the table is the first surface. At the same time, you have got one more surface here, the surface of the box. So between these two surfaces, there is certain amount of force which is opposing, and that particular opposing force is known as friction, right? And this particular friction is of three different types. One is static friction, kinetic friction, as well as rolling friction. So basically we have got three different types of frictions. One is static, kinetic, as well as rolling friction. So in the case of static friction, suppose that you have an object on a particular surface like this, a horizontal surface, on a horizontal surface. Now this is something, suppose that if it is something equal to some 100 kgs, and this particular 100 kgs bag you want to move from point A to point B, you want to move from this particular point to this particular point. In that particular case, we need to apply more amount of force because this is a horizontal surface. So as long as the surface is horizontal, the frictional force that comes into picture is what you call it as the static friction. And this particular static friction is high, right? The static friction is high when compared to kinetic friction, and kinetic friction is high when compared to rolling friction. Three different types of friction. When you compare the values, static friction is very much high when compared to kinetic, kinetic is very much high when compared to rolling. But what is kinetic friction? Now here in this particular case, the same bag of 100 kgs. Now this particular bag of 100 kgs is placed on an inclined surface. Here it is a flat surface, but here you are using a inclined surface. When you are placing this particular bag of 100 kgs on a particular inclined surface, you apply the force for a certain amount of time, maybe from this point to this point, and then leave it. After that it starts moving on its own. So there in that particular case, you need to apply the force only for a certain period of time and then leave it, then it starts automatically moving. But whereas here in the case of your horizontal surface, you have to move from point A to point B completely, then only we'll be able to move from point A to point B. But the same is not the case here. So in the case of an inclined surface, you push the object to some extent and leave it. The object, after traveling after some time, it just starts moving, right? Now the same thing on the same inclined surface. Suppose that if at all you are placing an object which is of 100 kgs, but it is something like this. It is something like this. Now there in that particular case, this object which is of 100 kgs, you just apply the force for a certain amount of time, just push it and release it, it starts rolling on its own. Here in this case, you need to push the object from point A to some distance, maybe up to point B, so that the object is reaching this particular point. In this case, from starting point to ending point, the force has to be applied. In this case, from point A to point B, stop at this particular point, the object will start moving on its own. In the last case, in the case of rolling friction, right at the point A, you apply the required amount of force and leave it. Then the object starts rolling on its own. So this rolling friction value is very much low when compared to kinetic or as the case of static frictions, right? So there in that particular case, if you just see the slides, right, now whenever you want to push this particular object on a horizontal surface like this, we need to apply more amount of force, but whereas in this particular case it just keeps on moving. When the object is like this, we need to apply lesser amount of force, right? But in the case of your rolling friction, the shape of the object will get deformed like this, the shape of the surface, or else the shape of this particular object at this particular point, wherever you have got the contact, it becomes flat to some extent. Now for example, if you observe your car tires, the tires of a vehicle, at the point of contact, this is the ground and this is the point of contact. At the point of contact, you will be finding that the tire is bit flat, but wherein the remaining portion of the tire, it's absolutely spherical in shape. But wherever you are finding some contact, it is finding certain amount of flatness. Right? So friction is of three different types. One is static friction, other one is kinetic friction, the other one is rolling friction. Of all the three, static friction has got the maximum amount of value and rolling friction has got the minimum amount of value. Right? That's it.